Hello, dear viewers. Hope you all are doing good. Besides GIS and remote sensing, I upload several video tutorials on environmental and disaster modeling, data analysis using significant recognized software. Anyway, here I'm back with another new video on stormwater management model. In the previous video, I have showed you how to download and install SWMM 5.1 version and explained the use of it. In today's video, you will learn a complete project where I will show you a design of urban drainage system. First, open software SWMM, then I will add raster file of my study area. For that, go to view, then backdrops, load, then backdrop image file. I'm adding the raster file of my study area, then click open and then click OK, and then go to view dimensions, check meters as map units, then flow units, it is in CFS cubic feet per second. I will change this as CMS cubic meter per second as flow unit. Then go to project and then defaults. You can see here ID levels, object and ID prefix. I will set for rain gas is R, then subcatchment S, junctions J, then outfalls O. Save as defaults for all new projects. You can check this on. Conduits C. Then click OK. Now subcatchment. So what is subcatchment? A subcatchment in the network represents the physical area from which a manhole or other inflow node collects water. And in other words, you can define subcatchments as hydrologic units of land whose topography and drainage system elements direct surface runoff to a single discharge point. The user, we are responsible for dividing a study area into an appropriate number of subcatchments and for identifying the outlet point of each subcatchments. In this in this exercise, I will draw 3 subcatchments for my study area. The second subcatchment of my study location. When you will stop drawing, just right click on your mouse, then it will be stopped automatically and your subcatchment will be drawn. The third number of subcatchment of my study area. Right click on the mouse. After drawing subcatchment, you can remove the background image. For doing that, go to view and then backdrop, then unload. You can delete drawing. Right click, then go to options. You can see here map options, subcatchment, fill style. You can keep it as solid. Then again, right click and map options. You can keep it as cross hatch. right click on then options. I'm going to keep it as diagonal. You can increase or decrease the symbol size, border size. Options, annotation, check subcatchment IDs. You can increase the font size of subcatchment IDs. You can go to this option from tools, map display options. From map labels, you can give a specific name for each subcatchment. For that, map labels, then add object and click in the subcatchment. I'm going to give the first subcatchment as building 1. For second subcatchment, I'm going to write building 2. And for third subcatchment, I'm going to give it a name for building 3. After writing, click enter. I'm drawing 3 junction node for 3 subcatchment. Junction node 1, junction node 2, and junction node 3. And I'm drawing one outfall node for 3 subcatchments. So now I will explain what is node in SWMM. A SWMM network can include 3 different types of nodes: junction, outfall, and storage. So what is junction node? Junctions are drainage system nodes where links join together. Physically, they can represent the confluence of natural surface channels, manholes in sewer system, or pipe connection fittings. External inflows can enter the system at junctions. And what is outfalls? Outfalls are terminal nodes of the drainage system used to define final downstream boundaries under dynamic wave flow routing. Go to Tools, then Map Display Options, and Annotation. Check node IDs. Rain gauge IDs, and then click OK. Now node IDs is visible. Then add a conduit link. So what is conduits? Conduits are pipes or channels that move water from one node to another in the conveyance system. So I'm drawing conduits, that means pipeline, and connected to all manholes and outfall as well. That means pipeline connected to J1, J2, J3, and finally to outfall. Then go to tools and then map display option, annotation. No, follow arrows, check field, then OK. You can see here follow direction. Arrow size, you can increase the arrow size. OK. And this pipeline, I mean the link, you can increase the link size. You can change the background color from map display option, background color. I'm keeping it as white. Nodes, you can increase the node size. Node size has been increased. You can load the raster file again. Now I will link the subcatchment to junction. So here, changing the name, subcatchment is one, first subcatchment. Then outlet, for first subcatchment, outlet will be J1, junction 1. You can change, you can define the area, width, slope, and so many things here you will find. It depends on your study area and your design. Then second catchment, subcatchment. So second subcatchment name is 2. You can give here several information. So for second subcatchment, the outlet will be junction 2. And then area 32. And then for third subcatchment, the junction node will be J3. Define area, then outlet will be J3, junction node, I mean the manhole. So subcatchment and junction node are connected. Then double click on junction node. Here invert elevation for first junction. I'm giving invert elevation 7.2 meter. You can also put here maximum depth, initial depth, and others information as well. For junction 2, I'm giving invert elevation 6.7. Junction 3, double click on this and then invert elevation 6.2 for junction 3 node. Then for outlet, invert elevation I'm giving 5.8. Then you have to give maximum depth of conduit, I mean depth for pipeline. I'm giving 1.5 for third conduit, I mean pipeline shape. You can see here several shape of pipeline: rectangular, triangular, parabolic, force main, circular shape, close to rectangular. I'm selecting circular shape for my conduit. Now I will add rain gauge. Rain gauges supply precipitation data for one or more subcatchment areas in a study region. The rainfall data can be either a user-defined time series or come from an external file. Time series, add rain data here, time series name, 5-year return period, then add time and corresponding value. OK, then click OK. Now subcatchment for 1, set rain gauge R1, add rain gauge for all subcatchment, adding rain gauge for all subcatchment. The rain gauge are linked with the 3 subcatchment. Then you can run simulation from this option or from this option. So click run simulation and run simulation successful with some errors. Click here, summary results. You can see here summary results, subcatchments, runoff coefficient, then node depth, maximum AGL meters, average depth meters. So many information here. You can get information and essential information from here for your research purpose. Node flooding, outfall loading, link flow, maximum flow, minimum flow, conduit surcharge, create a profile plot, then initial node, then outlet end node, then find path to 3 conduits, then click OK. Then you can see water elevation profile, then click map. If I click on run animation button, you can see how water elevation works based on time. Now select precipitation for subcatchments, then depth for nodes and flow for links. Once we clicked on the animation simulation, we can see how the pipes change in color as the velocity of the water changes. Right click, you can change color ramp. You will find here several options: framed or non-framed. Then you can print the file, or you can save the file from here. You can export the file as map. Then you can export map to text file, enhanced meta file, or drawing exchange file. You can see you can save summary results from here. Print preview, you can print this file from here. Again, you can load the raster file. I hope you guys got a clear idea about SWMM model. I tried to show you how you can design an urban drainage system. The data I have used in this model is for just an example. I hope you learned how to draw manholes, pipes, subcatchment, and set rain gauge, adding data for all objects, and how to run the model and get data for your research or project purposes. In the help menu of SWMM, you will find manuals and many useful information. Anyway, in the next video, I will show you how you can design urban drainage system for more than 6 subcatchment. Till then, stay safe and thank you.